Hello and welcome to Math Time with Tati. Today's topic is finding all zeros for a polynomial function. The first thing that we are going to talk about are the definitions. The first word is a polynomial function. The definition above is the more formal one, and the definition underneath it is the easier definition, which is the sum of one or more monomials with real coefficients and non-negative integer exponents. The next word is constant, which is a fixed value. Next to it is an example, 2x squared plus 3x plus 4. The 4 is circled because it is the constant. Then the last word is leading coefficient, which is the highest degree in a given polynomial. The example is 6x squared plus 5x plus 10. The 6 is circled because it is the leading coefficient. Next, we're going to talk about things you should already know before attempting to find all zeros for a polynomial function. The first thing you should know is the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2. Next, you should know the basics of division. And lastly, you should know the definition of a polynomial function, which was discussed in the beginning of the video. There are two different methods to finding all zeros of a polynomial function. Those methods are long division and synthetic division. Today we are going to talk about synthetic division because it's easier to use. Finally, we get to the best part, the example problems. The first example is f of x equals x to the third power plus x squared minus 10x plus 8. First thing that you have to do for this equation is find the possible rational zeros. For the constant 8, we have to find the factors, which is 1, 8, 4, and 2. And for the leading coefficient 1, the only factor is 1. Then we do the positive negatives for all of them. So we get positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Then we're going to plug in 1 to the equation because it's easier and we can find out if 1 is indeed a factor. So we plug it in and then we get 1 plus 1 minus 10 plus 8. And then we add them up and get negative 10 plus 10. We do it again and we know that it equals 0, which means that x minus 1 is indeed a factor for this polynomial function. And then we're going to do synthetic division. For synthetic division, we're going to put a 1 on the outside, and then the inside, we're going to put all the coefficients, which is 1, 1, negative 10, and 8. Then we're going to put an arrow underneath the first one, because it's a given, and then we're just going to do 1 times 1 equals 1. And then we add them together, we get 2. 2 times 1 equals 2. Negative 10 plus 2 equals negative 8. Negative 8 times 1 equals negative 8, and then 8 plus negative 8 equals 0. Which means that our new polynomial function is x squared plus 2x minus 8. Then we're going to put the original polynomial function equaling to x minus 1 and x squared plus 2x minus 8. Next, we're going to factor that and get x minus 1, x plus 4, and x minus 2. And of course, we're going to equal that to 0. And then after that, we're just going to solve for 0. We're just going to solve for x. So x minus 1 equals 0. So we add the 1 and we get x equals 1. And then we do that to the rest of them. And we get x equals negative 4 and x equals 2. So our final factors are x equals 1, x equals negative 4, and x equals 2. The next equation is more difficult. For example 2, we have the equation f of x equals 3x to the power of 4 minus 8x to the power of 3 minus 37x squared plus 2x plus 40. The first thing we're going to do is find all the possible rational zeros. For the constant 40, there's 1, 2, 4, 5, 8, 10, 20, and 40. Then for the leading coefficient 3, there's only 1 and 3. Now we're going to find the positive and the negatives, which are 1, 1/3, 2, 2/3, 4, 4/3, 5, 5/3, 8, 8/3, 10/3, 20, 20/3, 40, and 40/3. After that, we're going to plug in 1 to see if 1 is a factor because it's the easiest one to plug in. When we do that, we get 3 minus 8 minus 37 plus 2 plus 40. We equal that to negative 42 plus 42 and equal that to 0, which means that x minus 1 is a factor. We're going to do synthetic division. For synthetic division, we're going to put the 1 on the outside, and then we're going to do the coefficients in the middle, 3, negative 8, negative 37, 2, and 40. We're going to drop the 3, add the adding sign, and do 3 times 1 equals 3, negative 8 plus 3 equals 5, negative 5, negative 5 times 1 equals negative 5, and so on. So then at the bottom we'll have 3, negative 5, negative 40, and 0, which will equal out to 3x to the third minus 5x squared minus 42x minus 40. And then we're going to put it into the f of x equals x minus 1, 3x to the third minus 5x squared minus 42x minus 40. Since it's by itself, we're just going to, since it's a whole different polynomial, we're going to put it g of x so we don't get them mixed up. And we're going to try to find another factor. So the next easiest one out of our options would be 2. So we're just going to try the positive 2 first. So then we're going to plug in 2 for all of them. So we're going to have g of 2 equals 3, 2 to the third, minus 5, 2 to the second power, minus 42 times 2, minus 40. When we solve that, it equals to 24 minus 20 minus 84 minus 40. And if you mental math that and try to add it, it does not equal 0. So instead, we're going to do negative 2 instead, since we have the option to do positive or negative. So when we do that, we're going to have 3 times negative 2 to the third, minus 5 times negative 2 to the second, minus 42 times negative 2 minus 40. And then that equals to negative 24 minus 20 plus 84 minus 40. And then we're going to have negative 84, not negative 84, 84 minus 84. And then we equal 0. And then that indeed means that x plus 2 is a factor. So we only got to trinomial, we have to do synthetic division again. So instead we'll put negative 2 at this side, and with the coefficients of 3, negative 5, negative 42, negative 40, we'll drop the 3, do 3 times negative 2 equals negative 6, negative 5 plus negative 6 equals negative 11, negative 11 times negative 2 equals 22, negative 42 plus 22 equals negative 20, negative 20 times negative 2 equals 40, negative 40 plus 40 equals 0, and that will equal us out to 3x squared minus 11x minus 20, and then we have f of x equals x minus 1, x plus 2, and 3x squared minus 11x minus 20 for our things. Now we will do the quadratic formula to finish off. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So if you plug everything in, you will then get 11 plus or minus the square root of 11 squared minus 4 times 3 times negative 20 divided by 2 times 3. And if you solve for the square root, you'll get 19. So then when you do the equations, it'll be 11 plus 19 divided by 6 and 11 minus 19 divided by 6. And when you do that, you'll get x equals negative 4/3 and x equals 5. And then for all of them, for this polynomial, it'll be x equals 1, x equals negative 2, x equals 5, and x equals negative 4/3 to find all the zeros. It's your turn. So the first one is x to the third power plus 5x squared plus 3x minus 6, and the second is x to the third power minus 4x squared plus 5x minus 2. I have all the answers in the captions below.